Okay, welcome back. We're on page 205 talking about logical operators. The first one is the not operator. It's just used with an exclamation point. And basically what it does, it just changes things around. In other words, if I was to use the not operator here, it just makes that thing exactly backwards, okay? Which is kind of dumb, and I'm not actually going to do that right now. But that's how that thing works. I rarely use the not operator in that regard. But the and the or operators, yeah, I use those a lot. And you're gonna have to learn this. Okay, I'm just saying you're gonna have to learn this. So let's talk about and or. All right. The English use of the terms is kind of confusing. If I walk up to the counter of a fast food joint and say I'd like a hamburger and a Diet Coke, I walk away with two things, right? So and means I get more. If I walk up to the counter and say I'll take a Diet Coke or a Diet Pepsi, I get one thing. So in that context, ordering at a fast food counter, and means I get more, and or means I get less. But the problem here is we're using the and the or in the context of an if statement, sort of like a filter. And if I make my filter bigger or stronger, maybe that's the right way to describe it. When I make my filter bigger, stronger, well then fewer things go through, okay? So, all right. So I want to know if my age is greater than or equal to 6 or or age is less than or equal to 12. Okay? That's what I want to know. I want to know if it's within the range of 6 and 12. Okay? Is that making sense? In other words, I'll take 6, 7, 8, 9, 10, 11, and 12. That's the ones that I'll take. So that's my filter. This would be, if I just did that, then that filter would mean, man, instead of having 6 correct answers, there could be millions of correct answers, right? That making sense? And if I said age is less than or equal to 12, and I didn't have this part, well, then millions of numbers would fit in there. You know, minus 42, minus 4,078, right? So when I add this back, then my filter is gotten bigger, stronger, and now there's only 6 answers that are going to be appropriate here. It's either going to be 6, 7, 8, 9, 10, 11, and 12. I guess that's 7. 7 answers that could go through this filter. Is that making sense? So the or means fewer things make it through. The and would mean, if I put an and there, well then, you see it kind of backwards? So now I'm going to say, yes, this is within the range. Dang it. Okay, cool. Let me just run this just to prove to you that the dang thing works. Yes, it's within the range. Okay, does that make sense? That explanation makes sense. So the or and the and. Okay, so here's the thing that I like to put on test questions. Are you paying attention? I absolutely guarantee this will be on at least one quiz and the midterm exam. So maybe you should pay attention. And that is, how do you convert something to its logical opposites? I have that, where I'm only looking for the numbers between 6 and 12. And then I come back later and I go, you know, what I really wanted was the exact opposite of that. So how do I convert this to its logical opposites? That's the thing. Okay. So the way you do that is, I'm going to fire up my good old notepad. All right, so if I want to convert that guy, which is greater than, what is the opposite of greater than? And if you say to yourself, well, the opposite of greater than is less than, no, it's not. You go, well, sure it is. No. If I said less than 4, and then you told me the opposite of that was greater than 4, what about 4 itself? Ooh, so the opposite of greater than is less than or equal to. Okay, the opposite of less than is greater than or equal to. Is this making sense? The opposite of equals is not equals. Kind of makes sense? Cool. Okay, so hey, remember, if the equal sign is involved in one of these things, it's always to the right. Okay, cool. All right, making sense to you guys? All right, so what I want you to do now, well, and let's do that's the comparison operators. Now let's do the opposite of the logical operators. And so an opposite of and is or. Okay? Now you've got it all. You've got every piece of information you need to be able to convert something. So in the examples I typically have, I'm going to have something like if age is less than or equal to 42 and I don't know, this count is less than 2. Okay, something like that. To convert this, you need to count the number of operators that you see. Well, I see I see one logical operator and I see 2 comparison operators for a total of 3. How many? 3. If you can count to 3, this will not be a difficult assignment for you to fix or a difficult quiz for you to answer. If you can't count to 3, we're going to have problems. So there are 3 operators. There's a greater than or equal to operator, there's an and operator, and there's a greater than operator. All 3 of them must be converted to their logical opposites. All 3 of them. Should I say that again? How many need to be converted? If there's 3 operators, how many need to be converted? Oh, just 2? No, all 3 of them. So it'd be like this. Age, what is the opposite of that guy? We'll look up on the chart. It looks like the opposite of greater than or equal to is less than. What's the opposite of that guy? Well, it's this guy. What's the opposite of that guy? Well, it's that guy. Okay, so this is not actually complicated. Not really. It's just the logical opposites. Okay? Good. So I'm going to go down here and we're going to do our logical opposites. So I'm going to do this again and say if age is less than 6 and age is greater than 12. Okay? Less than 6 and greater than 12. Which means less than 6 means it's everything from that side, and then 12 is everything from 12 and beyond. Okay? That kind of sort of makes sense? Cool. So I have successfully converted a compound if statement into its logical opposites. Yes, yes. You're going to need to know how to do that. Okay, on page 206, they start talking about branching. We've done this. We did an if statement. We've done lots of if statements. We've done the else statement. We've done the nesting. Inside an if statement, I could have another if statement. There's nothing wrong with that. So, for example, if inside here, I could just turn right around and say, if, I don't know, what else do I have? What do I call it? Key? Yeah. If key is equal to x. Hey, did I use lowercase x or uppercase x? Ooh, uppercase. That's not going to work. Key is equal to x. Then do something here, right? So this is perfectly okay to have an if statement inside an if statement. Perfectly normal. It's perfectly okay. All right, we're going to do another. And so up here, where let's just do another one down here. I'm going to say if first name is equal to Bob. First name equals Bob. Okay. Now this is one of those very strange things with the Java language. That did not set off any alarm bells. on line 57, it's saying, man, I don't see any problems with that. There's problems. There's lots of problems. That doesn't work. So when comparing strings, you actually have to do something different. I know, it's kind of weird. Just bear with me. And strings is the only time this happens. I mean, you can do practically all the primitives. You can just use the equal sign, right? And then all of the others, when you're doing the equality operator, it's actually comparing not the value inside the variable. It's evaluating the address. So, my address is 123 any street, and so all it's checking to see if the addresses match. It does not tell you who's home. Okay? So if you're trying to find out if I'm home, looking at my address can say, well, yeah, the addresses are the same. That's not the same thing. So I have to do something kind of funky here. I have to basically go in and say equals Bob. I know, that's really funky, and you only have to do it on the reference types. Okay? Cool. So nesting is common. We talked about that. There's an else if guy. If you have a bunch of these nested guys, then one of the things you can do is to shorten it up. Now a lot of this is for the benefit of the human, not for the computer, because the computer doesn't care. I'm going to go over here and create a method. We haven't actually talked about methods much, but I need to be inside my class. Okay, inside my class, but outside of this onCreate guy, which means right here. Okay. So I'm going to go here and say public, and then I'm going to write me a method. And the method is going to convert a letter grade, a numeric grade into a letter grade. Okay? So I'm going to say public, and it's going to return a char. Don't worry about that part. We haven't got to that part yet. Return a char, and it's going to call this thing convert to letter, and I'm going to ask it to send in, I don't know, a double, maybe? Double for a score. Okay. Now I know I'm getting ahead, so don't freak out too much. I'm going to say char answer is equal to F. And then I'm going to say return answer. It helps if you spell things correctly. Got it. Okay. Don't worry about what that means. That's not what I was trying to show you. So skip all that in your head, and let's just get down to, I need to go through and have some if statements, a set of if statements that basically say, is it, between 90 and 100, you get an A. If it's between 80 and 90, you get a B. That's how I want this thing to go through. Okay. So what I want to do here is have a series of if statements. They're going to be nested if statements, but I'm going to use this. Instead of having this thing cascade, it'll start off with one, and then it'll end it, and then end it, and then end it. That kind of gets old after a while. So using this else if statement, it's just for the humans. It makes it all line up a little prettier. So here we go. I'm going to say if score is greater than or equal to a 90. Okay? If it's greater than or equal to a 90, well then the answer is equal to, you made an A. Okay? That pretty cool? And then I'm going to turn right around and just keep going and say else if, and then keep the else if score is greater than or equal to an 80. Then I'm going to say answer is equal to a B. Okay, do you understand what's going on here? The reason I can do it this way is if the score is greater than 90, greater than or equal to 90, then you get an A, which means the else if will only run if this has not yet been satisfied. So if it's satisfied, this never runs. Isn't that pretty cool? So the first, it's like a sieve. I'm going through big holes in the sieve. Everything goes through, and then the sieve gets smaller and smaller and smaller and smaller. Okay, we're coming up on the 15-minute mark. You guys know how this works.